Hi everybody, welcome back. So the last thing that we're going to touch on with this video is the ways to calculate the three types of power that exist in this circuit. So I have my apparent power, which is S. I have my real power, which is P or my watts, and I have my reactive power, which is Q. So the beautiful thing about rectangular form is that I have all of the values necessary already calculated within this circuit. I have a horizontal or an active value of current, which is my 5.9. I have my imaginary or my reactive value of current, and I have my total circuit current that I would measure with my ammeter. So when I want to calculate the apparent power, all that I have to do is take my applied EMF and multiply it by my total circuit current. So I would get 120 volts multiplied by my 7.68 amps, and I get a 921 VA. The same thing can be done with power, and we have to remember that power is my real component. It is my active component. So when I'm multiplying and I'm determining which current, I don't want to take my total again because I'm going to come up with the same value, but I'm going to take my applied EMF, multiply it by my active current, which is my horizontal or the real value of current that I solve for. So that's 120 volts times 5.9 amps, and you would come up with 708 watts-ish, okay? The same thing happens when I go to calculate my reactive power. I'm going to take my applied EMF, multiply it by my reactive current, which is my imaginary value, which is my 4.9. One thing that's really, really important to remember, it's often like, what do we do with this negative? How is that viewed? Industry has determined that when power is being consumed, we are going to consider that a positive value. Watts is an absolute value. Whenever you calculate watts, it will always be a positive value. So because watts is always consumed, we are always, a consumer is using watts, and that will always be a positive value. Anytime a watt or anytime energy is being consumed, we're going to consider that a positive value. So because this is a lagging circuit and I have lagging VARs, those VARs are consuming, they're taking up space on my grid. I am consuming those, they will be a positive value as well. So when I do that calculation, it's important for me to remember that. Because if I were to, it was a capacitor, that's storing energy. That's kind of, in a way, giving back to our system. We have to deal with that appropriately. So 120 volts times 4.9 amps, I end up with 588 VAR. So just as a little note, I'm going to do this off to the side here. One thing that you can do, and just sticking with the real numbers, we're going to say note. If you want to do this, and it's important we just understand where this is coming from, I can calculate the, I'm going to write, because this is going to come up in rectangular form. So if I just write power, and in brackets here, I'm going to say real and reactive, just as a note so you see where these numbers is coming from. It's a little bit of a smudge there. If I take my 120 volts, multiply it by, it's kind of making a mess. Pen's getting a little old. Sorry about that. Clean that up quick. It's going to bother me probably more than it bothers you. 120 volts multiplied by, and then in brackets, I just use this value of current. I use 5.9 minus I at 4.9. When our calculator spits this out, what it will give is 708 minus, sorry, plus, because it's positive, 588. I. That's what will show up. Oh, it's dripping again on me. That's okay. So it's important. This is rectangular form all over again. And what we have to recognize is, what do these two values equate? Well, we did them here so you can see. And it's always my real and then my imaginary. So when I just leave it as a complex number and do 120 volts, my applied EMF multiplied by my current, hopefully that's not off the screen, and it might be. Anyway, that's 5.9 and I at 4.9. It's this value right here is what I multiplied by. You're going to get that 708 plus I at 588. Hopefully that's not off the screen, but I got a sneaking suspicion it is. But that's those two values. That's the rectangular form using the complex number to show that in phase and out of phase component, that real value and that imaginary value. So I hope this has helped. If you've got any questions, please feel free to reach out to me, ask away. I look forward to seeing you in the next one.